Yeah. So here I have extracted all the zeros and all the ones from our data. Now I have to take only 95% of zeros in our data and 5% of one, so that our data is much more real life oriented, and the model that we are going to feed also becomes much more real life oriented, because real life data looks like that. Real life data will never be like this, that 667 cases are genuine and 333 cases are real. Real life data will never be like that. Real life data will be that 667 cases are genuine and might be 20 or 15 cases are fraud. That's how real life data looks, right? So we are going to take 95% of 0 and 5% of 1. What we are going to use? We are going to use pd dot concat. Pd dot concat is basically pandas. Here I haven't assigned any nickname to pandas, so I will just write pandas. So pandas is the library that we use. Oof, 1 minute. So we have to use this library pandas, and there is a concat function in pandas, and with the help of this concat function we can do this. Okay, so let me write the code. We have extracted it is not df0, it is df1, and then pandas dot concat. What is this? It will connect these zeros and these ones that we have extracted. It will connect these zeros and these ones that we have extracted. Now within that concat you have to write a function. What is that function? You have to tell that how many zeros you want and how many ones you want. So our zeros are stored in which place, in which name? Can anyone tell me our zeros are stored in which place or which name?
df slash 1, df slash 1, df slash 0.
df underscore 0. Okay, so our df is stored in df underscore 0. So then we have to use this dot sample function. What is this dot sample function? It will basically allow you to take only a certain percentage, or certain fractions of the zeros. Now can anyone tell me in this df0 how many zeros are stored? In this df0 how many zeros are stored? No, 667. I haven't assigned here that I will take 5%. I have said, but have I written any code till now to take 5% zeros?
No.
So how many zeros are here in this df0? All the zeros that are present in our data. How many zeros are present in our data? 667. Right?
Yes.
So this sample will allow you to take up certain percentage or certain fraction of the zeros. Okay, then within this df dot sample we have to mention the fraction frac, that is the fraction. How much fraction do you want to be 0? 95% zeros are supposed to be taken, right? So we will give 0.95. 0.95 is basically 95%, and then you have to give random state. Random state is basically a parameter, and for simulation we take it. This has to be 42. You can it is allowed to take multiple values, but in real cases we take it as 42. So this part you don't have to change anything. In this random state equals to 42, take it as it is. And how many ones are there in our data? Our ones are stored in, right, 333. Our ones are stored in df1. Our ones are stored in df1, and we have 333 ones. Now we will again write df underscore 1. Then we will again use sample. Why are we using sample function? Because we want only a fraction of ones, not all the ones. Just like in case of 0, we are willing to take only a fraction of zeros, not all the zeros. So similarly for 1 also we are going to take only a fraction of ones. So what is the fraction that you want in case of ones? In case of ones, what is the fraction that is required to be taken? 5%. 5% means 0.05. and this part is constant. As I have told you, random state will be 42 always. Okay, so we have written the code. Now look, we have started the PD concat by this first bracket and third bracket. Have we ended this first bracket and third bracket yet?
No.
So we have to end it. We have to end the first bracket and then third bracket. Now this entire concating is done. In our new data we will have 95% zeros and 5% 1 in the fraud variable. But have I stored this new data into a name? Have I assigned a name and stored the data there? Have I stored this new data into a name or not? Not yet, right? So what can I do to store it? I can write df.new, which is a new name for our data, equals to. So now this entire code, that is pandas concat, whatever function it is doing, it is just taking 95% zeros and 5% ones. All of this is now stored in this df new name. In this df new name, all of this is stored in df new name. Clear? So whenever I have to call, yes, tell me.
So this random state 42, is this any kind of arbitrary value or just it's the state that is generating?
Sorry, it's not
This
an,
random.
it is a parameter. Okay, it is a parameter in the Python libraries. Whenever there are some, it's not arbitrary. I mean, I cannot say that it's an arbitrary, but it is a parameter. This parameter you will also find in train test split. You will also find this parameter in the some logistic models, sim libraries. So why 42? There is no such special reason. You can use any integer, but generally 42 ensures that you get the same result every time you run the code. That's why it is 42. There is no such intuition behind 42 that why 42. You can give any number, but 42 is a special number that is by default Python gives us same result. We run the code every time, you will get the same result if we give 42. If I give any other number, suppose 41 or 46, we might not get the same result every time you run the code. Okay.
So thank you.
Okay.
Sir,
Yes.
sir, why we took 95% of 0 and 5% of 1?
Because that makes
why
our
it is
data
necessary?
much more appropriate. If you want to take 90% 0, 10% 1, that is also allowed. It is anything that you can do with it. But in real life,
No.
the errors, I mean the frauds are quite less. I can assume the frauds are more less than this also. I can assume it 2% and 98% also. So that is also allowed. Okay. Clear?
Yes, sir.
Now if I have to call my data, if I have to recall my data, if I want to check my data again, what is the name of my data? Is it in the df now? Is it in the df yet? Or is it stored in anywhere else now? Can anyone tell me, is my data is still loaded in df or my data is loaded in somewhere else?
DF.
df underscore new. Okay. Now let me just run this code. Yeah, closing parenthesis does not match opening parenthesis. Okay, df new pandas concat. First bracket should be in the place. Sorry, first bracket, then third bracket. It should be third bracket, then the first bracket. Third bracket, then the first bracket. Yeah. So now it is properly obtained. Now if I have to check the ratio again, I want to check that how many zeros are now present in my data and how many ones are present in my data now. What will I do? I will again write the dataset name, then the column name, then again in the previous case whatever we have done here, dot value counts. This is the function that we will use, dot value counts. So dot value counts we will use. What is the dataset name now? What is the name of the dataset now?
DF underscore new.
And then what is the column name?
I
What?
think fraud.
Fraud, obviously. No, column name haven't changed. Have I assigned a new column name? Dot value underscore counts. And let me run it. Look, how many zeros are there in my data now?
6, 5, 4,
And how many ones are there?
7.
So is this much more close to
Seven
the
frauds are there.
right, 7 frauds are there, 0 and 654 genuine transactions are there. Is this more real or this was more real? Which model will be more real? If we feed our model this data, will this data be more real or will this data be more real? Second model. So that's why, look, you might think that what is the requirement of writing these 4 lines of code? What is the requirement of doing this pandas.concat and then extracting the zeros, extracting the ones, then connecting those ones and zeros by pandas.concat and then giving these fractions of 98% and 2%? What is the requirement of doing this? If I skip this part, I could have ended the class 20 minutes earlier. But I am doing this to make our data much more realistic and real life oriented, so that our model becomes much more accurate. And whatever prediction that our model will do will be also accurate. Okay. Now to done the logistic regression model, we have to define our x and y. X is the independent variable and y is the dependent variables. Okay. Dependent variable, sorry. X is the independent variables set and y is the dependent variable. So how to set the x? The code is written here. To give the independent variables in x, you have to write the dataset name and then you have to use .drop function. You have to write what? You have to write the drop function. Okay. Now what will you drop? You will drop those variables which are not supposed to be in x. You will drop those variables which are not supposed to be in x. That means which are not supposed to be independent variables, right? Clear? So I will just write x equals to, I haven't given a star here. Yeah. So I will just give x equals to, what is the dataset name? What is the dataset name? df underscore new, and then we will give .drop. We will use this drop function and then we have to give the variable names which are not supposed to be in our independent variables. Now tell me, which variables are not supposed to be in our independent variables? This is the information of the variables. Which variable is not supposed to be in the independent variables? Fraud, right? Any variable else? Transaction ID. Failed attempts will be in our independent variables. Why should we exclude failed attempts? Higher failed attempts means it will lead to a greater probability of being a fraud transaction. Right? Transaction ID will also not be in our independent variables, because in the description of the variables I have told all of you that transaction ID will not be used in any analysis. This is just a identifier of the transactions. So we have to exclude two variables. We have to exclude what? We have to exclude two variables. So x equals to df new drop. Then we have to give a first bracket, then a third bracket, and you have to give the variable name. What is the first variable name that you want to be excluded? That is fraud. FRAUD. And what is the second variable that you want to be excluded? The second variable is transaction ID. Why are we excluding fraud from here? Can anyone tell me why are we excluding fraud from here?
Because
Not the independent variable, that is the dependent variable. So
Fraud is going to be our dependent variable.
because that depend in a failed attempt. Directly depend on failed attempt.
Yeah, that will depend on field attempt, that will depend on many other variables also that are given here. Fraud is basically our dependent variable, so we will not take it in the set of independent variables. So that's why we are excluding this. Then we will close the third bracket.
Sir, why we include transaction ID?
Transaction ID is not of any use. It is just an identifier which gives us the identity of the transactions. Look, transaction ID is T001, T002. What will you do by taking it into your classification? Does it by anyhow impact fraud? No. Transaction ID is basically the TN ID that is being generated by after each transaction. So will it?
That not independent or dependent.
Nothing. It is not of any use. It is not independent or it is not dependent also. That's why we are excluding transaction ID. And then you have to give axis equals to 1. Axis equals to 1 is used to keep the data on the same axis. That means our data is stored in a column wise structure. So the structure remains the same if you use axis equals to 1. And what is our y? Our y to store y will be our dependent variable. So to make y, you have to give the dataset name. What is the dataset name? It is df underscore new, and then you have to just give the name of the dependent variable. It is very simple. Within a third bracket, you have to give the name of the dependent variable. What is the name of our dependent variable?
Fraud.
We want to predict the fraud, so our dependent variable is fraud. So we have made the x and y properly. Let me run the code. Syntax error, unmatched. Oh, I might have done something here. What is
ऊपर में axis equal to 1 वो green नहीं हुआ है.
what? Have I missed any commas? No, not yet. Axis equals to 1 is also properly given. What are you saying?
Line number 3, sir. Axis equal to 1.
Okay. Oh, okay. Very good. Thank you for pointing out. This is being treated as yeah, now it is properly running. Actually, let me show you it again. Okay, it is not happening. Why? Key error. Transaction ID not found in axis. Transaction ID. Have I probably I have made a spelling mistake. Transaction ID. Yeah, transaction ID. D is also in capital
There
letters.
is no underscore.
No, underscore is there. Underscore is there. Check it again. Underscore is there, but I and D both are in capital letters. But when I have written it, I have given D in small letters, which I have corrected just now. That's why it was not being operated.
Axis 1 means?
Axis 1 means it will keep your data in the same structure which was earlierly present. I mean, the structure the data was holding in the earlier case, it will remain the same. I mean, the structure will not be broken. Okay. These are some random things. I mean, not random. These are some by default things which you have to maintain every time. This axis 1, random state is 42. Okay. So axis 1 means the row wise structure will be maintained. Let me just write it for you also. So axis equals to 1 means row wise structure maintained, or row wise sum will happen. Sum means basically not addition. Sum means the data will be one by one appended. And axis equals to 0 you can also give, which will not give here. It means column wise sum will happen. Column wise sum will happen. Column wise sum. Sum means not addition. Okay, I am telling it again. Now we have to fit our model. So this is the code to fit our model. We have defined our x and y. That means we have defined our independent and dependent variables. Now it is time to fit our model. So how can we fit our model? The code is very simple. We have to apply this train test split. Now, have you seen this train test split in the earlier part of the class? Have we imported this train test split? We have imported the train test split, as you can see in the beginning of the class, from the module called sklearn.model selection. So now you might be getting idea why have we imported these libraries in the initial part of the class. So now we will use this train test split, and by using this train test split we will fit our model. So in the train test split you have to give 4 things. What are the 4 things? You have to give the name of your independent variable. You have to give the name of your dependent variable. You have to give the test size. I will explain this test size. And you have to give random state. Random state is 42 because I have already mentioned that random state 42 means every time you run the code you will get the same result. So can anyone tell me what is the meaning of this test size equals to 0.3? Look, when we are fitting this model, Python breaks the data. It breaks the data and it creates 2 set. It creates 2 set. One set is called training set, one set is called testing set. And my question to all of you is, our model will be trained on which set? Training set or testing set?
30% of the data is allowed.
Okay, we'll come to that. Don't hurry. I mean, I'm just asking you the question first, that the data is being divided into 2 parts. Python at first divides our data into 2 parts, training set and test set. What do you think? In which part our model will be at first trained on which data? On the training set or the test set? At first our model will be trained. So our model will be trained on which data? Training set or testing set? It's not a very difficult question. The set named as training set. So our model will be trained on training set, na? Are you getting my point? Suppose you have 10 data points. So Python basically separate these 10 data points. Suppose it can take 8 data points in training set and it can take 2 data points in test set. Now when Python have to make your model, make your regression model, it will take the help of these 8 data points which is stored in training set. It will take the help of these 8 data points which is stored in the training set and it will make your model. It will make your model. Clear this till this part? Okay.
So basically, I didn't get the point of the training set and test set.
Okay. So let me just go through it. In econometrics, when we do this, we don't create this training set and test set. That is not applicable to econometrics. Econometrics takes the entire data. That means if we have the 1000 data points or 100 data points, econometrics will take this 100 data points at a whole and it will give you a model. It will give you a model. That means it will give you the coefficients of the model, whatever results is required. It will give you the entire model is given. So there is no concept of predicting it. But in machine learning, if you have 100 data points, it will do 2 things. It will not just give you a model. It will do 2 things. One, it will create a model. It will create a model. Till this part it is just like econometrics. It is also creating a model. And in the second function that will machine learning do, it will test the model also. It will test the model, that how accurate the model is. Okay. So when in econometrics we are doing this, we are taking the 100 data points at a whole and we are taking the model as given. Model is given. So we don't have to break this. We don't have to create this training set, test set. But in machine learning, we have to at first create a model and then we have to test the model. Now, if you want to test the model, where will you find the data for testing the model? If you have 100 data points, 100 data points means you have these variables, transaction ID, then fraud, then merchant type, all these 100 values, 100 data points. So how will you test the model? You have to separate some data points. Suppose you have separated 30 data points, and to test the model you kept it aside. তুমি ওটাকে ঢাকা দিয়ে রাখলে, কি জন্য ঢাকা দিয়ে রাখলে? তুমি পরে ওই 30 ডেটা পয়েন্টস নিয়ে যে মডেলটা তৈরি হবে সেই মডেলটাকে টেস্ট করবে। টু টেস্ট দ্য মডেল ইউ হ্যাভ kept this 30 data point aside, kept these 30 data points aside, data points aside. Now how many data points do you have now? Out of 100, how many data points do you have now? 70. You will make your model, you will create your model with the help of these 70 data points. Create a model with the help of these 70 data points. Okay, so this 70 data points is your training set. You are making your model, you are training your model by the help of these 70 data points. And when your data is ready, your model is ready, your model is ready. Now তোমার কাছে 30টা ডেটা পয়েন্ট আছে। এই 30টা ডেটা পয়েন্ট এর তুমি প্রথম ডেটা পয়েন্টটাকে নিলে, নিয়ে প্রথম ডেটা পয়েন্টের একটা মার্চেন্ট টাইপ আছে, প্রথম ডেটা পয়েন্টের একটা ট্রানজ্যাকশান আওয়ার্স আছে, লাস্ট ফেলড অ্যাটেম্পস আছে, এই ভ্যালুগুলো আছে। এই ভ্যালুগুলোকে নিয়ে তুমি একটা ফ্রড হবে কি হবে না সেটা প্রেডিক্ট করতে পারবে। সেটা কোন মডেলের উপর প্রেডিক্ট হবে, কোন মডেলের উপর অ্যাপ্লাই হবে? এই ট্রেনিং টেস্ট, এই ট্রেনিং সেট থেকে যে মডেলটা এসছে সেই সেটের উপরেই তো অ্যাপ্লাই হবে, রাইট? সো প্রেডিকশনটা হয়তো হলো যে 0, ভ্যালুগুলো নিয়ে প্রেডিক্ট করলো তোমার মডেলটা 0। এবার এই যে 1 নম্বর ডেটা পয়েন্টটা, 30টা ডেটা পয়েন্টের মধ্যে থেকে এই যে 1 নম্বর ডেটা পয়েন্ট, সেই 1 নম্বর ডেটা পয়েন্টের তো সত্যি সত্যি একটা ফ্রডের ভ্যালুও আছে। এটা তো তোমার মডেল প্রেডিক্ট করছে 0, কিন্তু একটা ফ্রডের ডেটা পয়েন্টও তো আছে, কারণ এই 30টা ডেটা পয়েন্ট তো তোমার কাছে পুরোপুরি ছিল। এটা তোমার নতুন ডেটা পয়েন্ট না, তুমি সরিয়ে রেখেছিলে সাইডে টেস্ট করবে বলে। তো তুমি তোমার ডেটাতে গিয়ে দেখলে যে হ্যাঁ তোমার ডেটাতেও 0 আছে। তার মানে তুমি কি বলতে পারো? তোমার ডেটাটা ভালো কাজ করছে, তোমার মডেলটা ঠিকঠাক কাজ করছে। এইভাবে তুমি তোমার 30 ডেটা পয়েন্টসের মধ্যে থেকে সেকেন্ড ডেটা পয়েন্টটাকে নিয়ে আবার করলে, দেখলে তোমার ডেটা বলছে 0, কিন্তু অ্যাকচুয়াল ফ্রডের ডেটাতে আছে, মানে অ্যাকচুয়াল ডেটা পয়েন্টটা বলছে 1। তার মানে এখানে তোমার মডেলটা ঠিকঠাক কাজ করলো না এই ডেটা পয়েন্টের ক্ষেত্রে। এইভাবে তুমি 1 2 3 4 করে 30 অবধি চেক করবে, and you will get an idea how much well your model is working. তো দেখা গেল হচ্ছে যে 30 যে প্রেডিকশানস হলো, 30 প্রেডিকশানসের মধ্যে 24 টাইমস তোমার মডেল ঠিকঠাক প্রেডিক্ট করেছে। 0কে 0 প্রেডিক্ট করেছে, 1কে 1 প্রেডিক্ট করেছে, রিয়েল ডেটাতে যেটা ছিল সেটাই প্রেডিক্ট করেছে। ওকে, সো 24/30 into 100 is what? Out of 30, 24 times it has predicted right, so it is 8.
How we get 24?
I am just assuming it that out of 30 times, 24 times your model has predicted rightly. It has predicted 0 as 0 and 1 as 1. Okay, now this is 80, and interestingly this 80% is your R square. That is the amount of correct predictions made by your model, that we call goodness of fit also. In econometrics it is interpreted in a different way, and in machine learning it is interpreted in this way also. Okay, look, this is not the scope of class, but still you have asked, so I have explained. Clear now?
Sir, can you explain from that 30 I didn't understand from that 30.
From which 30?
That 30 aside for a test
For
model.
test, yeah, so we will test from that 30 আমরা 30টাকে নিয়ে টেস্ট করব না, যে 30টা ইনপুটস নিয়ে টেস্ট করব, প্রথম ডেটা পয়েন্টটা নিয়ে টেস্ট করলাম।
Can you speak English? I don't understand.
Okay. So by the help of these 30 data points we are going to test our model, that whether our model is working properly or not. So you have taken the first data point, you have taken the first data point's independent variables value, and you have predicted the outcome has come as 0. Now you have the output also for these 30 data points, because these 30 data points were kept aside from the real data, so you have the output also for the real data. That means you have the fraud value, dependent variables value present for the real data also. So now you have to check with the real data that it is correct or not, is it predicting correctly or not. So that is the functioning of the test set. It is the working of the test set. This test set is kept aside to check the functioning of the data, to check the predictive capacity of the model. Okay.
Okay, so they check all 30 and give the final result.
Yes, give the final result and then they match those final result with the actual value of the dependent variable. Actual value means actual values of the fraud variable.
Okay.
So suppose there are 24 cases where your model is corrected properly. It has predicted zeros as zeros and ones, and the remaining 6 cases it has failed. So what will be the proportion? It will be 24 by 30 into 100, na? So it is 80%. That means your model is predicting correctly in 80% cases. So it is a good model in a way, but although that context refers. Clear?
Okay. Yes, sir.
So now, as I have told you that how much percent or how much proportion should be kept in the training set and how much proportion should be kept in the test set. For that, this test site parameter is used. If you give 0.3 in the test size, that means 30% of the data is in the test set and 70% of the data is in the training set. Clear? If you give 0.4 in this test site, that means 40% of the data will be in test set and 60% data will be in the training set of your model. Are you getting my point now?
Yes, sir.
And random state is 42, so we have to give 4 things in train test split. One is independent variable x, one is dependent variable y, test size, that how much of the data should be kept in test set and how much of the data should be kept in training set, and then random state. Some of the participants, one of the participant was telling about this. Now you can tell me, what are you telling? That 30% you mentioned. I don't know the name actually because I haven't seen the screen. Okay, whatever, if she or he is there, then okay. So this is the concept of training set and test set. Now this train test split, it basically yes.
I would also like to know that the adjusted R square, like, can we explain it from this train test split?
Train test split, we can explain it, but it will require a derivation which will not be compiled. I mean, it is we can do it any other day. Okay, I will definitely explain it.
Yeah.
I mean, it will require some time. That's what I am telling.
Sir, can I connect you on LinkedIn? I just saw your profile, I think.
Okay,
Sorry.
okay. Yeah. You can connect me. Okay, so we have, with this train test split, we have basically train test split. What it does, it create 4 set of values. One is x train, one is x test, one is y train, one is y test. Okay, now so it is creating a set of training data of independent variable x. It is creating a set of test data on the independent variable x, it is creating a training data on y and it is getting a test data on y also. Okay, now we have to fit the logistic regression model. So we will train our logistic regression model. So for that the code is very simple. You have to write logistic regression, but if you write the logistic regression only, it will not work. Before that you have to import the logistic regression, which we have initially done in the initial part of the class. We have imported the logistic regression right here by the module named sklearn.linear model. We have imported the logistic regression. Clear? And there is a one parameter that you have to give within logistic regression, that is max iter, that is maximum iteration allowed. Maximum iteration allowed. What is iteration? Can anyone tell me what is iteration?
Iteration, like we do it in simplex method sometimes.
Yeah, that is the concept of mathematics you are going, but in the context of machine learning, what is iteration? Or in the context of logistic regression, what is iteration?
How many times we repeat that process?
Very good. How many times you iterate that process to find the best result? Okay, to find the best result, how many times you iterate? Iterate means trying and trying and trying and again trying. How many times will it try? It will try 1000 times, and the best result out of this 1000 times it will give us. Clear?
Yeah.
You can give 100 in place of 1000 also. You can give 200 in place of 1000 also. So don't ask this question that why have I selected this number 1000. Okay? Clear? Now,
Yes.
why are we loading this logistic regression? We are loading it into a name. We are assigning or storing it into a name called model. And then we are just going to fit. Now, as I have already told you, our model will be created on which data? Will it be created on training data, or will our model be created on test data? I have explained it here. Our model will be created on which data? Training set or test set? Our model will be created on test set. Our model will be created. Training set. Now I have explained here. Look, training set, our model will be created by the 70% of the data. So when I am applying this model.fit to create our model, we are going to give what? Are we supposed to give our test set of the dependent and independent variable, or are we supposed to give our training sets of our independent and dependent variable? Training set. So this model, what does this model contain? It contains the logistic regression with the iteration, and then I am applying model.fit, and I am just giving the training sets, X train and Y train. So our model is fitted. Now let me just run this code. X is not defined. Okay, this X is supposed to be in small letter, that's why it is not defined. Because here the X is in small letter, and here it is supposed to be in small letter also, that's why it is not defined. Yeah, now let me run this cell. Yeah, look, logistic regression is being applied. Now we want to check the output. We want to check that our model is what our model is predicting. What our model is predicting. So for that we have to give a transaction value. We have to give new transaction value. So whatever transaction we want to give, look for the variables. We have to give this amount value, transaction hour, merchant type, online transaction, international transaction in last 24 hours, average amount of last 30 days, failed attempts. By giving the values of all these independent variables, our model will predict that whether the transaction will be fraud or not fraud. Okay?
Sir, can you repeat the last sentence once again, please?
I am just saying it. I am just saying that we will give inputs. Our model is fitted. We will give inputs, and with the help of that input, our model will predict that whether the transaction was a fraud transaction or a genuine transaction. Okay? Now you tell me, what are the independent variables here? What are the inputs that we are supposed to give to our model? At first we should give the amount value, right?
Yeah.
Okay, then we will give the amount value. Whenever you are giving this amount value, you have to give it within a single quote. Amount. And Then you have to give amount value. You tell me how much amount value you want to give. These are real data. Na? You are getting a new data and then you are going to apply it and see it whether the transaction is going to be fraud or not. How much transaction am I supposed to give? Tell me anything, any number that you want. Tell me any number, any transaction, any amount of transaction.
645.
Only 645. Okay, so a small transaction. Okay. Then after amount, I should give the next variable value, next input value. What is the next input? Transaction hour, right? So transaction hour means in which time the transaction has occurred, in which time of the day the transaction has occurred. So I will just give the transaction hour within a single quote, and then tell me what time do you want the transaction has happened.
11 p.m. So it will be 23.
23. Okay, we are giving it in a third bracket to cast it as values. We are casting it as values, that's why we are giving it in third bracket. You have to give it in the third bracket when you are giving the inputs. Then what is the next variable? That is merchant type. Now merchant type can be someone's sound is breaking. Merchant type can be 1, 2, 3, 4, 5, 6 or 0. I am not sure about the categorization of this, so I am just taking it as 1. 1 means electronics. The transaction was done in electronics. Next,
Online something.
okay. Online transaction, right? Online transaction 0 means it is a offline transaction, 1 means it is an online transaction. So what do you want? Do you want it as an online transaction 0 or 1?
1, sir.
1. Achha.
Then international.
Then international. Oh. International is 0 means it is domestic, not international, and 1 means it is international. So what do you want?
Domestic. So 0.
0. And look, when you see the result now, you will be shocked that it is very beautiful. The entire thing, the entire hard work will be justified then. What is the next variable?
Transaction in 24 hours, I guess. So.
Transaction in last 24 hours. Okay. Transaction in last 24 hours, it denotes the number of transactions in the last 24 hours. If it is 2, that means there are total 2 transactions in the last 24 hours.
Sir, what is the use of this method? Means that what is this method do actually?
It will predict whether the transaction was fraud or genuine.
Oh,
Okay.
yes.
So now transaction in last 24 hours, how many times do you feel the transaction should happen in last 24 hours? 3. Okay.
Okay.
What is the next variable? Average amount in last 30 days. So transaction, why is it being copied? So what is the average amount do you want in the last 30 days?
So
3.
does it depend on the amount we set?
No, it doesn't really depend on the amount, because this amount refers to the amount of transaction on that particular day, on that particular time. So that can be a small transaction, but you might have done very big transactions in the other days of the month. So
1,000.
1000, okay. Then failed attempts, we have only left failed attempts. Is it in capital letter? Yeah, failed attempts. So what is the failed attempt that you want? Very key indicator this is. How much?
0.
0. Okay. So now whatever we have given here, we have to store it into a data frame. We have to convert it into a data frame. So to convert anything into a data frame in Python, we have to use pandas. We have to use pandas library. And within pandas library, we have a parameter called data frame. D should be in capital and F should be in capital. So you have to give pandas.dataframe if you want to convert anything into data frame in Python, and then a single first bracket and a single second bracket. So if I have started a first bracket and a second bracket to keep all this in data frame, I have to end this first bracket and the second bracket also. So I will end it here. Now as we are always doing, I have probably done a mistake here. Sorry. Yeah. Now should I store this data frame into a name?
Yeah.
Yes, sir.
So I am giving it a name. I am giving it a name of Q, capital Q, and I am running this. Okay. Now I will predict it is properly done. I will predict the fraud, whether it is a fraud model or whether the transaction was a fraud transaction or a genuine transaction. For that you have to just write 2 lines of very simple code. You have to use model.predict. Model is what? Model is where our logistic regression stored. Look, our logistic regression is stored where? Our logistic regression is stored here, na? So we will just take this model. This model is being taken to take the reference of that logistic regression. So let me just take here it model. Then we will use a parameter called predict. Model.predict. It is a parameter to predict the result. And what is model.feed? It is a parameter to feed the model. .feed is used to feed the model, and .predict is used to predict the outcome or predict the result of the model. Okay. Now we want to predict on the basis of what? On the basis of these inputs or independent variables, right?
Yeah.
So this is stored in Q.
Yes.
So we have to give the reference of Q here, that we want the model to be predicted on the basis of these independent variables or the values of independent variables Q. Do you want to store this into a name? This prediction, do you want to store this prediction into a name? So I am storing this into a name Dipto. You can give your name or any name you want. Now you can predict the probability also. Let me show this, and then I will predict the probability. I will just write Dipto to see the result. Look what the prediction comes. Array 0. 0 means what? 0 means what? Tell me.
Not fraud.
Not fraud. So does this look fraud by any chance? Transaction amount is 645. Why will someone steal your 645 rupees by using a credit card? But if I change this as 657, this is a big transaction, and then failed attempt to be 10, does it change? I am not sure about the data that whether it will change or not, but still I can try. Yeah, look, is it changing? A big amount of transaction is being done, and failed attempts were 10. That means that person was continuously giving or trying OTPs or giving pins or UPI ATM pins, whatever, and trying to steal your money. And look what our model is predicting, 1. That means the credit card transaction was a fraud transaction.
Sir, what is the requirement pandas.dataframe?
Pandas.dataframe is basically converting your entire data into a data frame. Okay. you cannot directly give it to Python. Python will not take it. So you have to store it into a data frame, a structured data format. I will explain this part of data frame if we teach pandas any day. Within pandas we have to learn all these things, data frames and arrays and all those. Okay. So now if I want to predict the probability of the model, that can also be predicted. For that you have to just write probability model dot predict, and then you have to give proba. What you have to give? Not, you don't have to write entire probability, you have to write proba, PROBA, and then you have to feed it the data. You have to feed it the data. Where is our data? Our input. Our inputs are loaded in queue, right? So you have to give queue. Do you want to store it into a name? So I am just storing it into a name Shayok, and then I am just printing Shayok. Look. Okay, it is coming as an array. Probably, oh, it is saying, probably it is saying, look, it is coming as an array, so 0.1 point. Okay, I'll just change the data, let me, so that the transaction also changes 1, yeah. Yeah, now look at this. What is the probability? The probability is saying 0.99. Ignore this value, this is not required. This is the value 0.99. What does it means? It means, look, this transaction amount is 657, failed attempts are 1. On the basis of this input, our model has predicted output to be 0. 0 means not a fraud transaction, it is a valid transaction. And what is the probability that it is a valid transaction? The probability is 0.99, that means 99%. What is the probability that our model is predicting that the transaction is valid, transaction is not a fraud, it is a genuine? The probability is 99%. Clear? বোঝা গেল? তাহলে আমাদের মডেলটা প্রবাবিলিটিও প্রেডিক্ট করতে পারে আর এটাকেও প্রেডিক্ট করতে পারে। ক্লিয়ার?
Yes, sir.
Now if I want to make it a little bit in a beautiful form, I can just add one line of code, that is I can just write predicted fraud within a double quotation, and you can just give it in this way, predicted fraud, and then if I write a comma and prediction. What is our prediction? Our prediction is loaded in Dipto. So Dipto, yeah, and if we just let me run it, yeah, predicted fraud array 0. Array 0 is basically let me just check if this array, no, it is not required. That means our model is predicting that predicted fraud is 0. That means it will not be a fraud, it is a genuine case. Clear? You can ignore this line also, it's not required, you have obtained your results here. But if you want to make it beautiful or look it to be beautiful, you can apply this line also.
What does it mean?
It is just the output being shown in the, here you are getting the output only by array 0. Here the output is being shown as predicted fraud array 0, nothing else. I mean just to visualize it in a more textual way, so that the output, if someone out of nowhere is seeing the output, get the idea. You can change it as prediction of the model, and see. So here you will get prediction of the model is what? 0. That means your model is predicting it to be 0. Okay. 0 means genuine transaction. Let's do this. Yeah, NP dot int. Okay, not required. Okay, clear? This not required. So have you received the proper idea about how to detect credit card fraud detection? We have done this entire coding from the very scratch, from a very minute level, and yeah, so we have received all the intuition about every line of topic. I have even reconnected our data. I have recorrected our data. I have removed some zeros. I have removed some ones, so that our proportion of the data becomes quite similar to the real life data. Then we have done this part, and then our model can now predict any output with the help of these inputs. We can give inputs here in this third brackets, and our model will predict the output, that whether that is a fraud transaction or a genuine transaction. You can sell this model to a banking system. I mean, obviously not with the help of only 1000 data points. For that you require very huge amount of data points and real life data also collected from the banking individuals or the banking related authorities, and then you can sell that model to your banking systems, so that whenever banking systems has to trace any violent transactions or any fraud transactions or any misguided transactions, they can trace it with the help of your model. Okay, so can anyone tell me that after doing this, what the banking system can do if they find that this transaction might look fraud? What the banking system can do? What is the utilization, or what is the ultimate profit that we are gaining after fitting this model? What will the bank do if they finds out that this transaction might look fraud? Can anyone tell me? Why the bank will take your model? Why the bank will buy your model and fit it into the system? This question is very important. It's not just learning the code. The bank will buy your model because if your model fits properly, if your model is accurate, and by fitting your model, if the bank can find out that which transaction can be fraud, the bank can block that card immediately and can restrict that fraud transaction to happen. If the bank fits this model into the algorithm and finds out that someone is continuously doing failed attempts, the transaction amount is also very big, the online transaction is happening, it is an international transaction also, transaction hour transaction in last 24 hours, he is seeing, the bank authority is seeing that the transaction in last 24 hours is 12. That is huge amount of transaction happening in last 12 hours. So the bank can immediately recognize by the model that it is 1. I mean, obviously bank will feed the model and see the output and find out that it is 1. And bank can stop the transaction and can stop the fraud to happen. Right? Right or not?
Yes, sir.
Okay. So is there any doubt in the entire code section or in the entire intuition section, whatever we have done till this part?
If the test size, then how it
Look, 70-30 is the optimum proportion. Okay. Now if we increase the test size, that means if we increase the test size to be 40% or 50%, then training size becomes smaller, right? And when the training size becomes smaller, your model is based on the training data, not on the test data. Test data is used to test the capacity of your model, how accurately it is predicting, but your model is entirely based on the training data. So if you increase the training, if you decrease the training data set or training data size, then your model might not become good enough. There is a concept of overfitting and underfitting also. If I get a chance, I will tell about this one day, that there are some data which work well in training data but doesn't work well in test data. That is what we call overfitting. And if opposite happens, that the model is working well on the training data but not working well on the training data but working well in the test data, that is called underfitting. Then there is a concept of bias variance trade-off that arises from here. So that there are concepts related to that also, but 70-30 is the optimum allocation. That is the one-liner answer from my side. 70-30 is the optimum allocation. Don't try to make any type of operations on that, because if you make your test size small